So we can see that the blood pressure varies in your body. So I already mentioned that arteries have a higher blood pressure than veins, and this is like dramatically seen in this. You can see that we start out with a pretty high blood pressure, and you'll notice that there is variation in the arteries because we have systolic and diastolic pressure. So that, remember, is when the heart contracts and when it relaxes. Then when we get to the arterioles, this curve is very steep. And so there we're going to have this pressure drop off really, really fast. Capillaries continue to drop off, venules, veins, and then in the vena cava, it's like almost non-existent, right? The blood pressure. And so this is why, one of the reasons why it's so dangerous and how you can tell whether or not you have severed an artery or a vein, because in the arteries, it's going to squirt out fast. And if it's a big artery, it's going to be like squirt, 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 and the blood is just going to be everywhere, right? But if you cut a vein, then it is just going to, it's going to come out an even, but it's going to be under much lower pressure. So the important thing here is to realize that the systolic and diastolic pressures only exist here in the arteries. And so we can talk about what is called the mean arterial pressure. So it is abbreviated as MAP. So this is the mean arterial, arterial, not arterial, arterial pressure. Now, this is actually a little bit different to actually calculate than simply just taking the mean difference between the systolic and the diastolic. So you notice here that it is actually a little bit lower than what you would do if you were just taking systolic and diastolic and adding them together and then dividing by 2. So we'll talk about that, the mean arterial pressure, but that's what is shown here. So because it varies with the pulse, right, the contraction and relaxation of your ventricles, we need to be able to calculate mean arterial pressure. We can also talk about the pulse pressure, or the pressure pulse. Pulse pressure, pressure pulse. I had it right. Pulse pressure. Okay, so this is the difference between the diastolic and systolic pressure. So systolic is higher, it's not negative. So diastolic and systolic and diastolic pressure. And remember, the pulse is just the throbbing of the blood as it moves through those elastic arteries, the elasticity of the arteries. So when we look at the mean arterial pressure, we can say that it is calculated by adding the diastolic pressure plus 1/3 of your pulse pressure. So my MAP equals the diastolic pressure minus, plus 1/3 of the pulse pressure. Okay, so let's do one of these. This is blood pressure 120 over 80. I'm sorry here, 120 over 80. Okay, so what is my pulse pressure? That would be 120 minus 80, right? So my pulse pressure equals 120 minus 80, which would be 40. And that would be in millimeters of mercury. So notice millimeters of mercury is my unit here. And then MAP would be equal to my diastolic pressure, which is 80, plus 1/3 of 40. So we would want to take 1/3 times 40. So that's about 13. And so my MAP is 80 plus 13, which would be 90 3 millimeters of mercury. And so you'll notice that the mean pressure, arterial pressure, is going to decrease as you move further from the heart. And then eventually when you get into the capillaries, it goes away at all, right? Because we don't have a difference in the pressures. The pressure is relatively constant in the veins and the venules. So let's move that so you can see that calculation. Okay, so let's look at what are some other things that affect our arterial pressure. So what are some things that affect MAP? One would be your cardiac output. So as you increase your cardiac output, like increasing your heart or like the contractility of your heart, which would increase stroke volume, you're going to get an increase in MAP. If you increase your peripheral resistance by decreasing the diameter of the blood vessels, by increasing blood viscosity and blood vessel length, then you're going to get a decrease in the MAP. So if we, increase in the mean arterial pressure. So as we do this, we're going to increase your arterial pressure. So why is this significant? Remember that high blood pressure is actually termed hypertension. And high blood pressure has a variety of effects on the body. So hypertension would be high blood pressure. One thing that it can do is it can damage your blood vessels, and it could lead to the formation of clots. It could lead to blood vessels being ruptured. It could also damage your kidneys and other organs as it goes into the capillaries. And so hypertension has a variety of bad effects. It can also affect your heart itself, because your heart, remember, has to pump against this pressure in your peripheral circulation. So it has to pump more forcefully. Another thing that could affect it is the coronary circulation. So remember, the coronary circulation are the blood vessels that supply the heart itself. And so that could be a very detrimental thing if your blood vessels that carry oxygen and nutrients to your heart muscle, to the myocardium, would also rupture. And so this is why it's important to keep your blood pressure down. And we're going to talk about the ways that your body is able to regulate blood pressure and keep it where it is needed to be.